Well, it worked enough for me to load this, so I should be fine for the slides at least. Alright, yeah, cool. You guys can't see those, okay. No problem. Nope, that's not working either. This is not. Okay, there we go. So, hi. I think most of you have I've either met most of you in person or I've talked to you in Discord at least once. But for those who have never seen me in person, I'm DeLap. I graduated from UML in 2021 with a dual bachelor's in biology and math. And then not immediately, started working on a master's in biology, was doing some computational stuff, found out that I liked the computational stuff better than the biology, and then went to work for SAIC as a cloud engineer on the Cloud One program, and that's where I've been ever since. So really what I'm going to try and do today in this talk is give a brief overview of how we got to Kubernetes in the first place. I think it's helpful just as you guys are thinking about either developing new tech or using state-of-the-art stuff. It's helpful to know the history of that, to know how we got to there and what problem Kubernetes as a tool was designed to solve. So we'll start at VMs. So most everybody in the room, I imagine, is familiar with what a VM is, key components of a VM. So you've got a host set of hardware, a host OS, hypervisor that runs all of the stuff to spin up VMs, and then you have your guest OS with applications, and you can create as many VMs as your hypervisor will allow. Sure. Anybody want to tell me some of the reasons that this would be inefficient or hard to maintain at scale? Chris?
More VMs are taking up like a specific amount of memory. It's not really dynamic. So if you have to put 4 gigabytes of RAM for that specific VM, you're kind of stuck doing that.
Okay.
There's a unique operating system between all the machines. Every instance has its own operating system, which can be a little heavy.
Yep, good. So there's a guest OS layer that's present everywhere that, especially as somebody in the security space, not only do I have to maintain that from a compute perspective, but now I have to figure out how to secure that. So it's an extra component that I have to maintain. What else?
I know it can also sometimes be difficult to share hardware with like GPUs and stuff like that amongst multiple VMs.
Yep, hardware acceleration can be difficult. That's not a problem that'll really go away, but it is definitely something to call out. The other thing, you notice how we're running multiple apps per VM right now? So that means that we're sharing file systems between applications most likely, which can get into all sorts of fun overwrites if you have stateful applications that are writing things to disk. Main reason for this was, especially early VM tech, there was only so small you could go. And so you were left in a catch-22 where you either had VMs that were hosting their own applications that were constantly underutilized, so you were poorly utilizing the hardware that you had available, or you have these multiple configurations that are hard to separate, and it's hard to avoid collisions between applications from a state perspective.
That also brings up the question of what happens when one of those apps, VM crashes. What do you do?
Yep, exactly. Do you blow away the whole VM and take down the other 2 applications that are running on it, or do you try and restore from a broken state? All right, good. The other thing I want to call out here is that this hypervisor, any bandwidth that is consumed by this hypervisor layer is entirely lost. Because the only thing that that is doing is babysitting all of the processes that are needed to run the guest OS. So you have another layer on top of your guest OS that's also being consumed that is just kind of dead space as far as your apps are concerned. So VMs, we've identified a number of problems. Another problem I'll call out is it's tough to manage at scale. So I've done 4 here for the sake of simplicity. With really big enterprise scale server farms, you can run like 200, 300, 400 VMs on a system. And there's some amount of configuration that you can automate or image away, but there's always going to be, every VM is going to be a little bit of bespoke configuration to get the application working. And it's really hard because you're effectively just running on a new server. It's difficult to automate that in a repeatable way. So that's virtual machines. So that's step 1. And we're like, all right, there's a lot of stuff running. There's a lot of overhead here. There's a lot of stuff that has to run at very privileged levels of the kernel. Like all of this bandwidth is running in root space. There's some of the guest OS that has to interact through the hypervisor to touch root space on the host hardware. So how the heck do we secure this? How the heck do we isolate our file systems? And how the heck do we get rid of some of this overhead? So that is where we get to containers. And the first unique thing about containers is that they were able to run entire applications and everything that was needed for an application in user space. So there's no need, and we can get into some exceptions later with stuff like FIPS and some stuff that has to touch the system. But aside from edge cases, everything can run in user space now. So we've also gotten rid of our hypervisor layer, and because of things like Docker volumes, we can now partition an isolated file system that looks the exact same for every application, even if it's using different space on the host system. Anybody want to point out some challenges within this setup?
We've still got multiple apps running in containers. They're not fully isolated.
Yep. You could try and get around that by separating it off so you have an app per container, but that, especially as we get more modern, we start getting into microservices, that becomes a challenge.
I guess networking can be a little difficult.
100%. That is the biggest sharp corner, in my opinion. Is there's
Networking meaning within the different apps?
Or container to container mostly.
Okay.
Yep. Yeah, so because every container is spinning up with within a local network that Docker or whatever your container engine is running, it's really hard to reason about and route between containers within the network.
I see that Docker creates a Docker 0 like network interface. Is that what the containers use to communicate the host system?
Honestly, by the time I came into industry, like the industry standard was Kubernetes. So
Okay.
I have not, beyond like very simple 1-2 container applications, I haven't managed anything with just Docker, to be honest.
I know this kind of OS stuff, but do you mind quickly explaining the difference between user and root space?
Oh gosh, I'll explain what I can, but I don't
Yeah.
get that low on the stack very often. So, user space is pretty much everything that we would typically think of as a computer. So that's any sort of GUI application, anything outside the boot sequence, realistically, for the most part. root space is really like kernel level, the stuff that is actually interfacing with your hardware to tell the hardware what to do in machine code. I don't know if anybody in the room is more familiar and wants to expand on that, and so down to learn.
That's pretty good.
Okay.
That's pretty rough overview of what it is.
Cool. So yeah.
Oh yeah, I have a question. So, why exactly is networking difficult with Docker? Like, can't you just run all the apps on separate ports?
But yeah, but how do you keep it straight? Which port is which? Like, which container is exposed on which port? Especially, again, this is a simple, like, for container, you're running 7 microservices scenario.
Yeah.
How does this scale up to hundreds of containers?
Yeah.
I guess that brings me to my next challenge of most of you have probably written a Docker file at some point. How do you handle a build system and a deployment system that has to now Docker build and Docker run hundreds of containers, network them together, and again, how do we deal with failure? So even in the container, like even in the raw container paradigm, there are significant challenges with trying to get things to run reliably at scale. There are definitely some tools like Docker Swarm out there that have alleviated some of that.
So, maybe this might be helpful for the people who are new to all of this. Like,
Yeah.
why would you want to have VMs and containers in the first place?
Okay, gotcha. So that's fair. I completely skipped a layer because I was like, everybody's worked on a server before.
Couple new people here. So.
Yeah, no, for sure. So, okay. I'm trying to think of how to do this with the existing stuff that I've got here. So, let's say instead of all of this, I just had my laptop, right? So I'm trying to run inserts production service here on my web server. So let's say there's like 4 different app components that I have to manage and deploy. Let's see, we'll say I'm running all of that in Python. So I have 4 different web servers running on Python. First of all, I have to find a way in my terminal environment to run all 4 of those processes at the same time in the background and have a way to debug all of them effectively. And then you get into some of the same challenges, so like even within a single VM like this, where you have multiple apps running on the same operating system, you start to get into those same state challenges that we had before of like, I have application 1 that writes to this place in the file system, and then application 2 comes along and writes to the same place in the file system, and now whatever data that I wrote for application 1 is gone. And there is no recovering that, and now application 1 is in a broken state. And again, we're back to, what do we do in cases of failure? With a VM, at least there is the option to blow it away and re-image it. You can re-image a server if you want to. It is a long and painful process.
It involves remoting into the IPMI terminal.
Yep.
Which is a term that, how many people know that here? Show of hands. 1, 2, 3, 4.
Yeah, I'm not gonna put my hand up because I know it's all of SAIC's, all the stuff I've worked with at SAIC is cloud-based. So.
So
Yep.
your example of with just one system, you're saying multiple, the apps are not isolated, so
Yep.
they can kind of fight each other or mess up each other's work.
Yep.
With the file system.
Yep. Yeah. Exactly.
So with VMs, you get like separate systems basically.
Mm-hmm. Yeah. The other thing too, and I mean this is even going back a little further, but if you're running stuff on just physical servers, there's also a logistics component to it of like each application is going to consume so much memory, so much CPU, so much RAM. how do you order and maintain that equipment in a way that's remotely feasible from a cost perspective, right? Especially like, I guess this would mostly be in like the pre.com boom days. But let's say you have a service that suddenly becomes really popular and you weren't expecting that demand. If you're not running with some amount of surplus all the time and you're running on one physical system, you're always running at a deficit. You're never using your resources efficient. So yeah, is there?
Oh, one more thing you could say is, well, what if you have leftover like hardware resources or CPU time? Maybe you can like, if you partition your systems, multiple VMs, you can have like other guests come in and use the other CPU time. So I guess it's the point of cloud. It's like leftover servers
Yeah.
left out.
Exactly.
You could also think of it from like a security standpoint too, because typically if you run an application right and you want users to interact with it, it would be good to have some abstractions between it and like the base system that it's running on. So if the application is compromised, like how far can
Yeah, that's a good call too.
get into? So abstractions around your application are good. Keep it isolated from wrecking everything else.
Yeah. So I guess to like paint a picture with that, if I'm running my application in VMs and I have a security vulnerability in app 1 that allows an attacker that compromises app 1 to get down to this guest OS layer, they can only take stuff that's on this guest OS. They can't touch anything that's on the host OS. If you're running directly on the host OS and you have an app that gets compromised, now an attacker has access to anything that's on your host OS. Sorry. Yeah. So we talked about VMs, we talked about containers. Talked about a lot of the challenges, specifically networking and deployment at scale with Kubernetes, or with containers. And so now, enter Kubernetes. So, actually, another thing to bring up with containers, what happens when you need to replicate all of this to another server? Because you're very rarely running in a single server environment.
You network boot off the file server over there, so it doesn't even matter.
Yeah, well, you've still got to stand up all your front ends, though, all over again. So yeah, now we get to Kubernetes. We'll get to what these components are in a little bit. The thing that I really want to highlight here is that Kubernetes provides a core set of components. That means that you can deploy an arbitrary number of applications to an arbitrary number of servers, and you have a central way to control all of that complexity. You have a unified language with which to specify all of the apps and all of the resources and all of the network. Like all the challenges that we've talked about is really what Kubernetes is aimed at solving. Any questions on this slide before I kind of go into a little bit of pulling back the curtain on Kubernetes itself? No? All right. Keep rolling. So, honestly, the first time it was pitched to me, it kind of sounded like magic and fairy dust. Like, hey, all of these problems that you've had managing your server complexity and all of that just magically go away. I guess the one limitation that I'll say up front with Kubernetes, and this is getting better as the ecosystem matures, but originally it was aimed at container orchestration only. So if you had a workload that couldn't be containerized, you were out of luck as far as Kubernetes was concerned. But so we've got the legend up here. I'm just kind of going to go through these components one at a time. So we'll start with the API server. So where something like a Docker, something like a container would have you build your application, package it up real nice, and then deploy it. The Kubernetes API server does that for not just your application itself, but all of the networking around your application, all of the identity management around your application.
Where's the API server in the diagram?
It is, I thought I had my mouse on it.
Okay.
It's this central point that every single, oh, actually, quick language thing, because for whatever reason, whenever we decide on new frameworks, we have to come up with new names for common things. For Kubernetes, they had kind of 3 core components. So you had your control plane, which is all of the binaries that I'm going to talk about over the next couple minutes. You had your nodes, which is just a fancy name for your servers. So this is your hardware. And then you have pods, which are application units that are running on those nodes.
They don't have to be containers anymore. Okay, they can be.
Yeah, I'm not going to get into that here, but there's some pretty cool projects in that space that are bringing. It's a weird, like, I don't know. I feel like it's something that only could have happened after Kubernetes became the standard, because now people are like, ah, shoot, I really need a VM workload that I would love to run with all of the Kubernetes stuff that I've already invested in. So you have people that are trying to orchestrate that type of system using the Kubernetes API. But that's the other magic of the API server, is it provides a base set of tools, but it's also built to be highly extensible. So if you have a custom thing that you want to do that nobody's ever done before, there is a structured way that you can define what that resource looks like, how it interacts with the host system, and how people can configure it and deploy it to Kubernetes. If I could put a question. Okay. All right. So that's API server. API server talks most frequently with the scheduler. This is the thing that is managing, hey, how much CPU do I have? Hey, how much RAM do I have? So that your resources are always balanced and used efficiently across these nodes. We also have etcd. Etcd is probably the weirdest Kubernetes control plane component, in my opinion. It's literally just a key value store for all of the configuration information that Kubernetes needs. It's built to be highly scalable, highly available, all of the good things as far as like your DevOps people are concerned, so that your cluster can stay operational even if some of the control plane is failing. And then we have these 2 components up here. These are configuration managers and controller managers, apologies. So controller managers and cloud controller managers. Cloud controller managers are really just an abstraction on top of whatever cloud provider's API. It's like AWS has its own cloud controller manager that takes everything that you see in the EKS console and makes it a reality on the hardware side. The controller manager component is that extensibility layer that I was talking about. So you can go into Kubernetes and define a custom controller to deploy like your specific application or your specific set of tools that you want people to use. Yeah, all those type of things. And then there's a couple of node components. I'm not going to get into these too deeply. Kubelet is really there to monitor node resources and just report back to the API server about what's currently running on it. And then kproxy is that networking component that I talked about. So that's what's taking all of the applications that are running on a given node, and then networking that between nodes and out to the outside world. Yeah.
So the control plane runs on one server. It could be one or more. So
Typically, yeah, it's one or more. Yeah. But yeah, typically less than your total number of nodes. Keep rolling here. Okay, so now we're going to zoom in. We've kind of been looking at the broad view of how is a cluster set up, how is it all managed, so when I deploy a resource to Kubernetes, what actually happens behind the scenes, right? So I would talk to the API server, say, hey, I want to deploy this application. API server talks to the scheduler, says, all right, there's space on node, we'll say node 2. That spins up on node 2. The kubelet here reports back to the API server, says, yep, we're good to go. API server is also talking to any controller managers that it needs to get custom resources as it's deploying. And then it stores information about your application in etcd for fetching later. Any questions on that? Any deep dives?
I just wanna make sure that I understand. So you have like your control plane, which is one system, and then you could have any number of nodes on top of that, and you basically just interact with the control plane, say, I wanna deploy this application, then it figures out all the resource management, everything, so.
Yep.
Okay.
Yeah. So that's kind of.
I'm interested to clarify the difference between node and a node group and how that relates for the control plane specific.
Gotcha. So you're talking node group like EKS specific.
Sort of, yeah.
Okay. What do you mean sort of?
Yeah, I do mean EKS, but more sense in the, like, how does that, this might be a little later down the line, but like, how does that relate to scaling for the nodes versus node groups themselves? Are node groups more like, as they sound, just more of a grouping, or does it affect how the control plane does scaling of those?
Let's table that. So I want this to kind of be a 2-part session. I'm going to walk through a lot of the technical details of like how is Kubernetes structured, why is this a good thing, and then we'll actually build some code to deploy an EKS cluster together, so we can talk through the specific concepts of EKS at that point. Yeah. So now that we've kind of laid out how I would deploy a resource to Kubernetes, I'm going to zoom into a particular node, and we are going to talk about how pods are actually structured. So a pod can be made up of, again, similar to how a cluster can be made up of any number of nodes, pod can be made up of any number of containers. Those containers can all be networked together however you want within the pod. There is a pod level network that gets created whenever a pod is stood up so that stuff within it can talk freely. For the most part, there's restrictions that you can't put on that. But.
So people use Docker mostly or Pod? Does it matter?
Most of the time, I've seen people use Docker to build images, like that's the most, but neither of these are actually using the Docker VM. Kubernetes runs on top of Containerd, which is a more open standard for containers. It can accept any format that you throw at it. Yeah, so the pod level network is nice and all, but whenever you stand up a pod by default, it is open to that pod and only that pod because it's designed to be isolated, right? It's like storage is isolated, networking is isolated, everything. The only thing that could be exposed to any ports that you've explicitly exposed. So how that does this get to the outside world? This is where we get to the concept of services. And services in Kubernetes are literally as simple as, hey, I have this application running on this port. Can you please expose that application on this port to my users? And again, it's just a nice abstracted way to be able to simply network stuff, even to the outside world. Questions with that? Okay. And I've included a sample pod manifest here, which it's, show of hands, how many people here are familiar with YAML? Okay, good, a decent number. So YAML stands for YAML Ain't Markup Language. It is a recursive language definition, or yet another markup language, depending on who you ask. But it's designed to be a very simple, easy to read syntax. It's declarative, so rather than writing an application and having to parse through a bunch of variables to get an output, and those variables could change at any time. With Kubernetes and with YAML generally, you declare what your final state is supposed to look like, and then you let the cluster handle getting itself there. Reason I wanted to bring this up is really so you can see how simple building an application is, right? Like you're literally just specifying, I want to deploy a pod with this name, with these labels. That pod is made up of an Nginx container. It's got some environment variables, and it's exposed on port 80. And that's it. You send that off to the cluster. You now have an Nginx web server running in your Kubernetes cluster. As you might imagine at scale, this gets to become hundreds of YAML files, which is why if you've ever looked at memes in the DevOps space, you might hear people who work with Kubernetes a lot referred to as YAML engineers. Yeah, it's it fits, so we'll take it. Okay, that went back. Oh, yeah, okay. So we talked about containers earlier. We talked about problems with scaling, having to redeploy, or having to deploy applications individually per app. And a lot of you, or some of you might have noticed that with Kubernetes, you could very quickly get into a situation where your pods look pretty similar to the container setup we had before, where it's just a YAML file per pod, and we're kind of back where we started in terms of a lot of configuration sprawl. Nick.
I just want to make sure, so like the whole YAML thing would be kind of comparable to like CDK, where you're telling it what you want to be deployed, but like how define how it's deployed, and then it's all handled by.
Yep. Yeah, absolutely.
Is a pod, is that a container or is that a?
It's a set of containers. It can be however many containers you want.
Okay, is it usually a VM or no VMs?
No VMs. No VMs. It is literally just an isolated network with a set of containers.
Okay.
Yeah. There's a cool, like, if you want to dig one layer lower, Kubernetes has a bunch of components. Like, there's a bunch of examples of these. They're called container network interfaces. So whenever you spin up a Kubernetes cluster, you are actually creating an isolated private network within your server itself. So that's like your Kubernetes network. That's why services are so important, because that's what translates between the internal Kubernetes network and the outside world. So each pod gets its own network interface within that internal network. And that's how you keep networking separate. That's how you're able to route between pods without having to have a bunch of IPs on hand. Yeah. So like, good example.
Each container would not have its own IP, but like.
It would, but it wouldn't, if that makes sense. So any traffic that comes, so we'll get into this a little bit later with my HOMA setup, but anything that connects to this from the outside world would just connect to my public IP. And then all the internal routing is done by something that I have in my Kubernetes cluster. Inside the Kubernetes cluster, there's like 1,000 IPs worth of internal space.
So it's similar to like the way that you would have a home network. I mean, the way that you'd have a home network. Like
Yeah, you'd have
internal IPs, and then things route through the router, and that's what actually sends the traffic.
Yep. Yeah, so it's another layer to that. But yeah, so you very quickly get into, and if you have, again, we'll talk about like modern microservices architecture. Some applications that get deployed have like 200 plus components that make up that application. So deploying things at scale, even with Kubernetes, you end up with pod 1 through pod 200 that you have to do an individual command for. Whereas, so this is again Now we're gonna solve that problem. Enter Helm. So Helm markets itself as the package manager for Kubernetes. Really what that means is if I had this application and I had pod 1 through 4 of, hey, this is these 2 containers, this is these 2, et cetera, et cetera. The other thing that you can get with Kubernetes that is harder to get with Docker, just to go back a little bit, is resource isolation. So even with Docker, there are ways to limit how much resources a container can consume, but it's difficult. Like, it's not easily out in the open. With Kubernetes, you can literally set limits on, like, I want this to chew up a total of 1 core on my machine. And the API will handle doing that for you. But yeah, so if I have this sample application that's made up of 4 pods, I define a chart.yaml that says, hey, these 4 pods with this general configuration makes up my application. And I have a set of values that say, this is how I run this application in production. And if I wanted to deploy that application again to a dev environment, let's say with about half the space, I can change a couple parameters in this dev values file, and it will it'll automatically adjust everything in that application. So Helm is the main way that we're going to talk about. We're about to jump into the Home Lab section. Helm's the main thing I'm going to use when I talk about deploying applications. Before we get there though, this is, no joke, this is an actual diagram that I pulled from the Cloud Native Computing Foundation's website. This is the current state of the Kubernetes ecosystem.
Looks simple.
Yeah, super easy. So some of the things that we're going to talk about, right, like Helm, the thing that we just talked about that is its own package manager that takes probably about 2 weeks to learn, is here. So if you start to feel overwhelmed at any point with the Kubernetes ecosystem or with some of the stuff we're talking about, that's normal. I still get overwhelmed when I look at stuff like this, because I know maybe one of these services in every category. But yeah, there's a lot of space here. If you guys want to explore more stuff, yeah.
So question then, is this kind of like a node or an NPM situation where there's just like a ton of packages that do similar things and it's kind of like pick your best tool for this, or is like all of these do something separate?
It's kind of space dependent, to be honest. For the most part, it's an NPM situation.
Okay.
Yeah, of like, so the example I'll use is continuous deployment systems. So like things that actually get you from Git, like from having files in Git to things in a cluster. The 2 main ones are Argo CD and Flux CD. Literally the difference is one has a GUI and one doesn't. That is it. So, yeah. So we're gonna do a little bit of an ecosystem tour. That's right, you're working on it this summer, right? Yeah. So, okay. I'm gonna try and do my best to walk through some of the concepts here. This is taking everything that we just learned about Kubernetes and making it production creative. Like, this is how enterprises are actually doing this. First concept that I gotta introduce is something called GitOps. This is, again, kind of a Kubernetes modern DevOps thing that's happening right now. But actually, show of hands, how many people in the room are familiar with Git? Okay, nice, almost everybody. So for those who aren't, Git is a version control system for like files on your machine. So it means that you could, like, say you're editing a Word document and you make an edit, don't quite like it, you can hit the undo button. Git is undo, but for every file and every type of file.
fun fact, 2 days ago was the 20th anniversary of Git.
Yeah.
So,
Yes, sir. Yeah. So again, another application that was built around, this is a problem that nobody has solved. And it's causing me pain. So yeah. So what GitOps does is says, this repository is the source of truth. This is how I want my application to look. Figure out how to make my cluster look like that. And so Argo stands in the middle of Git repos, and we'll see in a second here, but you can literally, so whenever I was building this out the first time, yeah.
I'm guessing is, well, you use Git to keep track of your configurations.
Yep.
So basically, from that configuration you deploy stuff, right?
Mm-hmm.
With Git, you can keep track of the configuration, so you can roll back
Yep.
if something doesn't work. So is that basically the concept?
It's being able to make your config public. And it's also, I guess, oh gosh, where was I going with that? It's also eliminating a step. So like a lot of times, if you're running without a GitOps system, you push a change in your code base. Maybe it goes through peer review, maybe it gets merged, and then there's somebody or something that has to run a deployment pipeline in order for it to actually make it into production. GitOps takes out the middleman. So it literally says, all right, cool, as soon as this is merged, it's going into prod, or it's going into a dev environment for staging, or whatever you're like comfortable with doing. But it's aimed at taking out the middleman because we all use Git to track our configuration anyways. Yeah, GitOps is something that I am super passionate about and trying to implement like pretty much everywhere I go right now at work. So if anybody has more questions about that or just wants to nerd out about that, I would love to. But yeah, let me get my Argo server port mirror.
I guess quick question, do you recommend defining your configuration in the same repo as your source code, or do you recommend a different repo for that?
I would say different repo, especially because most of the stuff you'd be deploying with Kubernetes is containerized. So that way you're separating your container image publishing from infrastructure deployment. So there's a bunch of local testing that you can do because you're building your container image separately. And then you also, again, it adds another option for rollback, right? Because now you're versioning your source code independently. You can do new releases, and then when you're ready to bring them into production, you can bring them in. If it fails, it's a simple one-click rollback. Well, maybe, hold on, can I move this? Okay. Okay, I gotta figure out how to get this screen to mirror effectively. All right, that seems like it's way too small. I'm gonna try and get this mirrored, and then we'll. Oh, another isolation concept for Kubernetes. Things can run in their own namespaces, which is how, like, within a cluster you can separate one application from another.
So Linux.
Yep.
use Ansible at all?
Yes.
Do you use GitOps and Ansible together, or are they traditionally like used very separately, one for DevOps, one for GitOps?
That's a good question. There are things you could do in Ansible that are GitOps friendly. I would say most configuration management tasks that you would normally do with Ansible are not.
Okay.
Or you would want some sort of intermediary between them. So you'd want like an Ansible tower or Ansible automation platform in between. There we go. Alright, everybody go to localhost 8080. No, nobody? Yeah, I was hoping to have this more production ready, full disclosure. I spent my entire Saturday trying to front Argo with the thing that we're going to talk about next, and just banging my head against the wall because Argo's documentation is wrong. Give me 1 sec to pull the initial admin password. Okay, no, but I want another terminal window. I don't just want the one.
Control-Alt-T.
Man, it's quick.
Is Flux the other one that doesn't have a UI, and is Argo CD the one that doesn't?
Yep. And I've been doing all of this from a remote machine, so I genuinely forgot to deploy the Argo CLI to this machine. Oh, thanks, Yermo. Okay. How are we gonna do this?
We would not let you go on.
It might let me go on the guest network. Whenever it logged me in, my DNS was like, I don't recognize this. And died.
Here, I can set up a guest network for you, and.
Oh no! If you're gonna do that, I'll set up a hotspot. It's all good. That's a good idea though.
Hotspot.
I kinda have to depend on that too, cause since I graduated, they won't let me on their Wi-Fi.
Yep.
It does get annoying.
Wait, what are you trying to set up right now?
I'm trying to grab the initial admin password so I can actually log in and show you guys what Argo looks like. But I forgot to install the CLI for Argo.
Pro tip in the future, using something like DevBox, which is a wrapper around, what is it called?
Alright, I guess we're just gonna curl bash here. Is it a wraparound VirtualBox?
No,
Or-
it's what's the other? Hold on, I'll look it up. It's the
Or is it the dev containers?
Nix packages. So
Okay.
DevBox it's a wrapper around Nix packages, so you can define all the CLI tools you want in one file, and then do DevBox shell to open them up. So it's really handy instead of having to manually use curl like that. For setting up new developer environments, I love it. So it's called DevBox. It's separate from Dev Containers, which is usually Docker containers. So they can work together though. So you can generate a Dev container from your dev. I use both.
small, where do you want me to bounce to?
Yeah, right there. So, so those are individual clusters, right? Which means
Yes.
each one has its own API server that's managing all this stuff. So when you're at this layer, like how is this what we have here with Argo CD? How is this different from like it's like a higher level from what we had before.
Mhm.
Now you have one thing managing like a bunch of other separated API servers that are all managing their own things.
Yep.
Is that like a problem that you run into? Or?
Well, no, because Argo defines its own, so there's an Argo controller manager, right? So there's custom resources that Argo defines that let you run the same application across multiple clusters without any issues.
Oh, okay.
Yeah, there's a whole bunch of stuff under the hood that Argo does that is just completely abstracted away. Whenever you are using it, and I cannot, there we go. Okay. Sorry, I was hoping this was gonna be less clunky. Okay, I'm just gonna log in as the default admin user because, again, I spent all day trying to get something to front this. I expected to have something else done for authentication. Okay. Oh, I had a bunch of demos. That's right. So, I'm not going to actually create and run an application here because the application that I would be deploying is the one that we're going to talk about next, which I already have a separate demo for deployed to this cluster. So there's a good chance that I would break things. But so the thing that we're gonna talk about next is Istio. If you look at the repo that was linked in the announcement, there's a full set of Argo manifests to be able to deploy all of the base components for Istio using like a bootstrapped cluster with Argo on it. But normally you would create an application here and it would load quicker than that. Oh. Okay. Alright, I'm gonna kill that. Normally, what you would say, well, I can just jump to internet, I guess. Is there's a set of, hold on, can I even blow that up enough to see? There we go. Yeah. So there's a set of application resources that Argo is deploying to your cluster as part of an application. That application links to a repo somewhere that defines all of those either in a Helm chart or in another Kubernetes compatible way. The main other one that I'll throw out there is Kustomize. And then, yeah, it's just all managed by Argo. And if you were to make changes to this, it's showing a manual SIC here. You can set up automated sync, so as soon as you push to like a particular branch of your repo, it automatically gets integrated into your cluster. So like whenever I was setting this up originally, my Istio cluster, I noticed that I had made a mistake in one of the values files that I was passing it. Made the change, pushed it, within 10 seconds it was in the cluster. So yeah, so that is a little intro to Argo. Hopefully this comes back up, good. All right, next thing we're gonna talk about is Istio. So I mentioned earlier that Kubernetes has a network layer to it. that network layer is good for starter applications. It is not super comprehensive. It'll help you with routing between pods, exposing something to the internet, but it doesn't do anything beyond that. And when you're running in production, you have things you need to think about, like certs. Like, how many people are familiar with the concept of zero trust here? Okay, so I'll give a quick. Effectively, trust no one. That's my little intro pitch of zero trust. The idea is that you should design your application, design your architecture, assuming that everybody is out to get you and steal your stuff. And so what that means is every network hop should be accompanied with some sort of authentication that says, I am this person, let me in. Istio is responsible for automating all of that. So whenever you deploy Istio to a cluster, there's a few different things that get deployed. And I'm going to speak with them because honestly, I realize that we've been at it for a little bit, and I want to get to the hands-on portion. But Istio's got a control plane, which is your controller manager that we talked about earlier. So it's handling all of the Istio-specific resources that you deploy. And then there's a bunch of different kinds of ways to route with Istio that all end up going through these zero trust tunnels that are deployed to every node in your cluster. Those handle any connections in between pods. And because you're managing all of that centrally with Istio, whenever this is really cool for somebody like me, I can absolutely go more in depth about why it should be cool for you if we need. But whenever you deploy something with Istio, you automatically get network isolation, you get mutual TLS, and you get the ability to control down to the process level what is and isn't allowed to connect to your application. See? I am going to skip some of the demos. So Kiali and Prometheus are really cool because they let you visualize that whole network. Once you have Istio deployed, there's a central control plane that is logging that you can now track. And so Prometheus is a really advanced metrics engine that is good at generating and pulling metrics from all the different things in your Kubernetes cluster. And Kiali is good at building these network visualization diagrams. If you're new to this whole space, highly, highly recommend these two tools. Because what Kiali will do is once you've got Istio up and running, it'll show you every single network hop in your cluster. It'll show you which ones are being protected by MTLS. It'll show you what's allowed and not allowed to hit all of those resources. And if you're interested in this, it'll also show you the performance of the network connections within your cluster. Last one we're going to talk about is Keycloak. Keycloak is an identity proxy. So you guys have all been to websites that have, I like to call them the Scout badge login pages, right? Log in with username and password, log in with Google, log in with GitHub, log in with Apple, log in with. Keycloak is aimed at making that not an issue. So rather than display a standard login pane, whenever somebody tries to hit your application, Keycloak says, actually, no, I need to know who you are first, and then I'll tell you whether or not you can access that application. It's a centralized place where you can define different authentication mechanisms, different users, different groups that those users can belong to, and then it will handle centrally federating access for those users to any downstream application. So that's kind of a tour. There's a lot more out there in the broader ecosystem. These are some of the tools that I've found really useful for getting things up and running, which you didn't get to see, and then securing things once they are up and running. I want to briefly touch on kind of where things are going, what happens in production. So more and more what I'm seeing in my day-to-day is what I'm dubbing ecosystems as a service. So this one is called Big Bang. It's maintained by a group called Platform One. They're an Air Force software group that's designed at making it easier for people with containerized applications to get their apps running in production in the cloud. And what ecosystems as a service like Big Bang do is they say, hey, we know Kubernetes inside and out. We've worked with it for a long time. We know what our preferences are for those kind of core services that you saw in the ecosystem. We're gonna automate and maintain a secure set of deployments for those base applications so that whenever you're ready to put your application in the cloud, you just deploy Big Bang, get everything that we bring for free, and then deploy your application on top of that. Big Bang is really nice because it's one of the ones that's been around the longest. It kind of kickstarted the whole revolution in this space. And so it's got some of the most mature deployments of some of the most popular applications within the Kubernetes space. The one that I am super excited about that SAIC actually just announced a partnership with is UDS, so Unicorn Delivery Service. This is provided by a company called Defense Unicorns, which is really aimed at not just deployments where you're connected to the internet, but deployments where you can't be connected to the internet for insert reason here. The main way that they accomplish this is something called Zarf, which is a really neat CLI tool that it's open source, highly encourage checking it out. What Zarf does is take insert application here and package all of the containers, all of the charts, all of the CLI tools, all of the deployment instructions down into a single compressed file format that you can take with you anywhere and deploy anywhere without ever connecting back to the internet. And the unique thing that I'll say about UDS before we kind of get into just kind of labbing out on our own here, is with UDS, so a lot of what we've talked about, right? We've talked about Istio securing your network. We've talked about Keycloak securing your identity space. We've talked about Argo doing unified CD. With what UDS has done is build their own custom Kubernetes resources where their customers don't even have to worry about defining, like normally with something like Big Bang, you at least have to define all of the resources for those applications. With UDS, you bring them your application as a package and they instrument it with all of the stuff in the cluster.
I'm curious to clarify a little bit about Zarf. Is it designed to be mutable? So once we do combine all the things that we need for our Kubernetes application, is it designed to be editable or modifiable after we've done that, or is it only a one-time thing and you can't?
No, it's designed to be immutable.
Okay.
So the main use case for something like that is like edge or heavily regulated systems,
Okay.
where like there are some places I go where before I go there, everything that I'm about to bring in with me has to get scanned. There are, right, like the use case that they always bring up is they're deploying and managing software on a fleet of Navy subs. Like once you package an application up and get it on a sub, there ain't no going back. But with something like Zarf, you can at least radio back to the people who do have internet access and be like, we need another package.
Interesting. So is Zarf itself kind of like almost like a container image artifact, or does it bundle that with YAML configuration to deploy on the system? How exactly does that work?
It's a little bit of a mix. So Zarf doesn't have the YAML configuration. UDS adds the YAML configuration element, so you can run like arbitrary commands. Like, yeah. Yeah, Zarf is more meant to get everything that you would need to deploy your application in one place.
Okay.
But yeah. That is it for me.
Is UDS closed source or?
It's all open source.
It's all open source.
Yep.
So UDS and Big Bang are both open source.
Yep.
Do they have GitHub repo?
They do. So Defense Unicorns has an org on GitHub that has all of their projects. So if you're interested in checking any of those out, you can go to github.com/defenseunicorns. And then Platform One as a whole open sources a bunch of their stuff. So you can go to, I believe it's p1.dso.mil if you want to learn more about what there is to offer on that site. Yeah, that's it. All right. Do we want to do picture and then we can kind of break off however makes sense to start building out a cluster?
Sure.
Cool.
All right.
And is there a particular time that we have to be out of here, or?
We've got room until 9:30, so you can go as late as you want.
Rad.
But people probably have to leave before then.
Yeah, people can leave whenever. I'm gonna stick around with whoever wants to stick around, and we'll let this out.
All right.
That was way too much new information. All at once.
Let's see, maybe we could use the webcam. Is that,
Dark down.
Like, how much of that content that you explained that you think you actually understood? Like, do you knew from beforehand?
yeah, it's like,